Hey guys, make sure you are on page 122 in your textbook. Okay, so pause the video and open to that page. So this says, Title IX addresses the number of athletic opportunities provided to different sexes, but the actual participation of schools may differ. Also, the same person may participate in multiple sports. At Vista Middle School, 5 out of every 7 girls play sports. So what that means is 5 girls out of 7 girls, right? But I'm going to erase this because it's girls that play sports, okay? The guidance counselor, Ms. Shanahan, and the athletics director, Coach Culpepper, are completing reports about the students at Vista Middle School. So again, we have 7 girls. Out of 7 girls, 5 of those girls play sports, 1 or more sports, okay? Consider the information each person knows and use the constant of proportionality to write equations for each situation, okay? So constant of proportionality. So this says, we have our guidance counselor, Ms. Shanahan, knows the number of girls in the school on a given day, and she needs to be able to calculate the expected number of girls who play sports, right? So she's going to be looking for the ones who play sports, okay? So I'm going to, for each one of these, I'm going to change up my variables. So what I'm going to do this time is I'm going to say, since we're calculating this, I'm going to say the girls who play sports, that's going to be Y. That's what we're calculating. We want to calculate the expected number of girls who play sports. So remember, there were 5 girls who play sports over 7 total girls. I think that may be a little easier. Okay? So, determine the constant of proportionality. So, over here, we have 5 over 7. Okay? Actually, let me restart that. We have those that play sports over total. Okay? So, total, and I'm going to put girls that play sports. I'm actually going to call that Y, right? That's what we did before. So 5 play sports out of 7 total, okay? So our job is to solve for Y. That is our job, okay? So if you don't remember we did 5t and 7y. 5 times t, 7 times y. And remember, we're solving for this one. This is telling us what we solve for. So I want to solve for y. That means I have to divide by 7 to get this alone. And if you remember, we normally would put 5 over 7t. Okay? So y is, oh, I don't want to put it that way. So remember y equals kx? Well, this is kind of like x here. My k is 5/7. Okay? Now I have to do this again. So y'all may want to do it over here. If y'all can show your work over here. See if I can move this a little bit. I don't know if I'll be able to or not. Oh, looks like I can. Okay. So then this says, Coach Culpepper knows the number of girls participating in the sports during a given season. So Coach Culpepper knows how many are playing the sports. Okay? She knows the number that represents 5, basically. And she needs to be able to calculate the expected total number of girls. So these two people need to know opposite things. Okay? So I'm going to change this up. Remember, we have sports, we have total, we have 5 girls that play sports out of 7 total, and we have, again, Y and T. We're calculating the total this time, okay? So in this case, I'm going to change this. I'm going to change that to X, okay? So X will be sports in this case, okay? So we're still going to cross multiply. I'm just changing this up a little so we don't get confused about Y equals KX, okay? So that would be 5T over here, 7X, okay? In this case, I'm solving for total, so I'm solving for T. So that means I have to divide by 5. So T is equal to 7 over 5X. Okay, so again, Y equals KX. So our constant of proportionality is 7/5. So notice these are reversed. Okay? This one is when I am looking for the number of girls who play sports. This is when I'm looking for the total, and I'm given the kids that play sports. Okay? So these are reversed. It just depends on what it is we're looking for. Again, generally we use Y and X, but in this case, changing up our variables a little bit. Okay? So it says define the quantities that are changing in these situations. So the variables that are changing would be T for total, right? Or total and the ones who play sports. Okay? The ones who play sports were either Y. I'm not going to put the variable because we changed it on these two. So let's just take that. These are the 2 variables that are changing. Okay? Now I probably should have just used what we used before, but I do want to look so I can make sure that I give you the right equations for this. Okay. Okay. So here's one equation. Y equals 5/7 T, and T equals 7/5 X. Okay. So this is if I know the total. Okay. So I'm actually going to erase this. Okay, and see if I need to use it. Oh, I don't know why I did that. I wanted to erase most of this, but I did not want to erase. Sorry about that. This one over here. Okay. So we actually already did this. It says use the constant of proportionality to write equations to determine the information for each person. Now we can change this up. So for the guidance counselor, remember we had Y equals 5/7 T. And for this one we had T equals 7/5 X. I probably should have used S for, or I'm trying to think what I should have done, S for sports, but I never like using S as a variable because my S's and my 5s look alike. Okay. In terms of proportionality, Miss Shanahan, and we may change this up based on our questions. In terms of proportionality, Miss Shanahan could state that the number of girls who play sports is proportional to the number of total girls in the school at a constant rate equal to the constant of proportionality. Okay? Write Coach Culpepper's situation using the language of proportionality and include the value for the constant of proportionality. Okay, so one thing I would do, which we've basically already done, right? We had girls who play sports and total, and the girls who played sports were 5 out of 7. And then for sports, remember we could put Y or we could put X. It doesn't matter, but we could put T down here, and we could put, I'm going to go on and put Y here because that's what we were solving for, okay? So T is total, that's why it's on bottom. Y is the total number of kids that play sports. This is the ones who play sports. This is total number of girls, right? So notice there's that constant of proportionality, okay? And then we already wrote our equation. So it says consider the given equations where Y represents the dependent, Y is dependent or output, and X represents the independent or input. That's normal. That's why we normally use Y and X. It's hard to say which one's dependent on these because it's changing the way they're wording the questions. Okay? So we're not going to be answering all of these, but let's go on and talk about some of them. Describe how the first equation represents the constant of proportionality. Okay, well, constant of proportionality is the ratio, just like what it says, the ratio of Y to X. Okay, K is the ratio of Y to X. K is the constant of proportionality, right? Explain how the second relationship represents a proportional relationship. Well, all we did here was we put K over 1. So, same as above, but K is the same as K over 1. Okay? Describe how the first equation was rewritten to create the third equation. So on this one, we want Y by itself, right? So I got to get Y by itself. Well, right now there's a divide. I don't want the divide. So I do opposite of divide, which is multiply. If I multiply the left side by X, I multiply the right side by X. Okay? So what did we do? Multiply both sides by X. That's how we get rid of this, okay? And then it says, explain the meaning of the constant of proportionality in the third equation, okay? It's basically just like this one, okay? K shows the relationship between Y and X. Okay. I know this is all kind of abstract. We're just kind of getting the gist of this. So hopefully you got a little bit of this. I don't think you probably got all of it, but hopefully you got a little bit of it.